So let's dive into a third example. In many applied problems, you'll be encountering some vocabulary that's related to the angle of elevation and the angle of depression. So I just want to spend a few seconds going over what the difference is. When you see either elevation or depression, it's an angle that is measured related to the horizontal. So you have to draw in a horizontal line, and the angle of elevation would be the angle that you would go up from there. So that would be the angle of elevation. The angle of depression is the angle that you would go down from that horizontal line. So a typical example is if you're standing on the ground and you are measuring the height of a building or looking up to the top of the building. This is the horizon line or the horizontal line, so this would be an angle of elevation. If you were in a plane and you're looking down at the water towards a boat, then if you draw the horizontal line from the view of the pilot and they view downwards, that angle is called the angle of depression. So we're going to be using that vocabulary in the next problem. So we've got two scuba divers, one here, and we'll call this guy number 1 and this guy number 2, and they're 20 meters apart. They both spot a shark, and the shark is down here, and diver number 1 spots him, and it's an angle of depression. So here's the horizontal, and the angle of depression is 47 degrees. And then we've got diver number 2, here's the horizontal, and he's going to take a look for the shark, and it's an angle of depression, so the angle between the horizontal and his line of sight is 40 degrees. So just to imagine which side do you think is going to be longer, this is a bigger angle here, and so this length here is going to be longer than this length. So we should be expecting that when we do use the trigonometry rules to calculate our missing lengths, and we want to find those lengths. So I'm just going to label a triangle A, B, C. So we're looking for little a and little b in this case. Now what's easy to find is this missing angle right here. It adds up to 180 degrees, so that means this is 93 degrees. So now I've got the makings for using the sine law. So the sine of 93 degrees, I could write it as 20 over 9 sine of 93. I'm going to put the lengths on top because those are the unknowns, and I'm going to first calculate b. So b over the sine of 40. Isolating b, I'm going to multiply both sides by the sine of 40, and I end up with b equals sine of 40 degrees times 20 divided by sine of 93 degrees, which equals 12.9 meters. So I just calculated this to be 12.9 meters. Next step is I'm going to want to calculate A, and I set up the problem again. This time I'm still going to use the same ratio, the one that was given as part of the problem, but this time use A over sine A, which is 47 degrees. So that means A equals 20 sine 47 degrees over the sine of 93 degrees, which equals 14.6 meters. And this is where we start to evaluate whether our answers are reasonable. We were expecting the light blue to be longer than the red, and that's what we found. So always checking against your diagram. So diver 1 is 12.9 meters away, and diver number 2 is 14.6 meters away from the shark. So this is another way of asking what are the assumptions you're making. Was there another way to answer this question? Here was diver number 1, and here's diver number 2. I assumed in the first question that the shark was between the two of them. But could he have been over here on the left side? So if I think about that, let's take a look at this. Here's diver 1 looking down. Here's the angle of the horizontal, and this would have been the angle of depression, which is 47 degrees. Diver number 2 spots the same shark, and here's the horizontal. The angle of depression is 40 degrees. So this triangle gives a completely different picture of the situation. So yes, there is another way to answer the question. Now, in order to set up the sign rule, we have to find 3 pieces of information on the blue triangle. This 47 degrees is outside of the blue triangle, so we've got to interpret that and actually calculate what this is, which is 133 degrees. And then we could go ahead from there to solve the triangle as we did before. Could we do it the other way around? In other words, if number 1 is sitting here and number 2 is sitting here, could the fish be on this side of the both divers? Well, the diver sees this fish, there's the angle of depression, which is 47 degrees, and diver number 2 sees this guy at 40 degrees. Now I think it's easy to see that this angle has to be larger than this one, which makes no sense for this diagram because 40 degrees is less than 47, so it doesn't make sense for this. This isn't a possibility, but this definitely is, and you could solve this triangle completely separately. So the answer is yes, there is another way of answering this question.